So things are moving fast in microbiome research, and you've had a unique, privileged opportunity to talk with world leaders everywhere. I'll bet you come up with some ideas about things you'd like to see people do that they might not be thinking about yet.
I would, and I think actually the best people in the field are thinking about this. So there's a lot of correlative work in the field, a lot of descriptive work. I think some of that is necessary, but we need to go beyond that. So if people are looking at connections between microbes, microbiomes, and diseases, then let's please look at try and do the types of experiments that will give us hints at causality, that will look at mechanism, for example. I would love to see a lot more longitudinal studies. Those are ongoing now, tracking changes in the microbiome over time to see whether those precede symptoms of disease or follow them. I would like there's a lot of reductionist work here. People look at vast communities and find one single in hominum, like one particular species of strain, and do experiments with that. I think there's obviously value in that, but I think there is also a role for systems level biology, looking at how these vast communities change over time. I would love to see more evolutionary work on things like the human microbiome. People who've worked on insects and other animal systems where microbial communities are a little bit simpler have done some fascinating work looking at how these organisms change in the course of an individual host's lifespan or over much longer timescales. And there's been much less of that in more complex human and like vertebrate microbiomes.
That strikes many of us here as a huge opportunity, just because the time frame is short enough that you can actually watch natural selection taking place within an individual's microbiome. And we can go back, for millennia and try to ask from our hunter-gatherer past and even other species, how has the coordination or the cooperation or lack evolved between these organisms and us?
Yeah, absolutely. I think there's a lot to play for in that space. I think it will require technological developments and slightly savvier techniques. So at the moment, a lot of the work in the field looks at, say, 16S RNA to work out who is where. Well, that doesn't really give you an idea of the types of changes we're talking about. You can see like the composition of the microbiome, but those broader evolutionary trends are hard to pass. Certainly, like within the course of within my body, like over the last few days or so, like depending on the food I've eaten, I'm sure I've seen there has been evolution going on within my microbiome, but we're not really in a place to understand it yet. And that's one thing that fascinates me, especially when we talk about how changes in our lifestyles might be influencing our health. We're talking about organisms that change on a very fast timescale. So could the changes we see, like the reduction in diversity, just reflect the fact that our microbiome is adapting to the conditions that we're providing for it? And are those things beneficial or negative?